there are many ways you can think about these talks. I have 2 talks back to back, and one is really very specific, and one is fairly general. But you can think about them as being, one is about the front of the eye, and the other is about the back of the eye, right? So things are very specialized in this world, and a lot of surgeons, for example, would work on the front of the eye and do things like cataract and LASIK and whatnot. And some will work on the back of the eye and take care of things like macular degeneration and diabetic retinopathy and the like. So you're in luck because I actually do both. And sometimes I think maybe I'll get arrested for doing both, but it gives you a good perspective. And then we'll talk about this. So this first talk is about the reduction of astigmatism. I'm going to go very quickly through what we mean by astigmatism and some historical notes. This is some credits here. And basically, Thomas Young, the famous Thomas Young, the physicist, towards the very beginning of the 19th century, discovered astigmatism by just looking at a little pen, pushing it back and forth, turning it around, and seeing that the picture was blurry in one plane, but if he pushed it a little bit to a different plane, it would become clear. And if he turned his pen, now it became blurry again, and he had to go to a different plane to get it clear, right? So that was the first view of astigmatism. Now, he is also, I'm going to come to this in just a second. Yeah, here he is. So he's done a lot of work on deciphering the Rosetta Stone and hieroglyphics. And that was finally clinched by Champollion, right? So I think there's kind of a very interesting analogy because he also started with astigmatism. And for, 2 centuries, essentially, we still don't have a perfect way of eliminating astigmatism. Now, astigmatism is very annoying because if you're nearsighted, if you're just nearsighted, then there's a place where you can see things, right? You have to bring things close and then you see them, right? And if you're maybe not nearsighted and sort of a little farsighted and reasonably young, then you can see far. So there's a place where you can actually have some, but if you have astigmatism, there's no near, no far, no nothing. Everything's blurry all the time in all planes, right? So it's particularly annoying. Okay, so what I'm going to be talking about is going to be related to the correction, mainly about the correction of astigmatism at the time of cataract surgery. So here are a couple of examples of cataracts. Once you get a fairly advanced cataract, you can't see much. And the evolution of cataract surgery is very interesting in its own right. And we have come to a point where we can very cleanly, very safely remove these cataracts, but also reduce any kind of nearsightedness, farsightedness, etc. And very recently, reduce a lot of the astigmatism at the same time that we are removing this cataract and giving this patient not only better vision than they had just before their cataract, but maybe better vision than they've ever had in their whole life. Okay, so here are just some numbers. The ways, so most people will have a little bit of astigmatism, half, 1. By the time you have half to 1, that's a lot of astigmatism. You have to get it corrected. And the glasses will correct up to a resolution of a quarter diopter. And people who present for cataract surgery, almost half of them can benefit from something, some intervention to get this corrected. So other than glasses, contact lenses, you can also do an excimer laser, something like LASIK, but that's a different procedure, more expense, more risk, etc. Then there are relaxing incisions, which are sort of by hand, cutting with a little knife, the cornea or the limbus, which is the edge of the cornea. Or you can do it with a femtosecond laser. That's a much more recent development. And these are done in the cornea. And I'm going to show you some numbers. And finally, you can do intraocular lenses. So now, very recently, we have these specialty lenses that are not spherical lenses. The lenses themselves have astigmatism. but they have just the right amount of astigmatism, hopefully, to cancel the astigmatism that you have. Now, these lenses, for obvious practical reasons, cannot be manufactured by, like, custom manufactured, even though we have, like, 3D printers and all of that. For now, they're produced, and they're produced in sort of steps. So that's one of the limitations. And if you do one of these lenses, you can get close, but you can still be left with quite a bit of astigmatism. All right? So this talk is going to show a technique, which is a novel technique, and that was developed, that I developed, and that I use Mathematica to kind of implement in a very quantitative and an exact way to reduce astigmatism to 0. Because as the abstract says, throughout history, we've been trying to reduce astigmatism, but typically it's done with one technique, and it brings you maybe close, maybe not that close with different variability, but you still have something remaining. But we are converging to 0, and hopefully this takes us essentially to 0. Okay, so here it is. This is how you can represent it. And the graph shows the color graph shows in the cornea, with the orange being a steeper, more curvature direction or meridian, and the green shows a flatter, less steepness meridian. And that's what it means for the cornea to have astigmatism. On the other side, you have some examples of how some of these lenses would be computed and positioned, and that's from one of the manufacturers of the lenses. Okay, so these are some of the companies that make these special lenses. In the United States, we have 3 such companies. Alcon came earlier. There was a different company that actually came even earlier than Alcon, but they are no longer in the business of manufacturing these lenses. They have some issues. So Alcon is around 2005, and for quite a long time, it wasn't that popular or as successful. There were some issues with the rotation and so on. And then you have Abbott, which makes Tecnis and Bausch & Lomb, and these are fairly recent FDA approvals, a couple of years. All right. Now, here's one of the problems that we have, that each company does not want to tell you about the other company's products, right? That makes sense, like Coke and Pepsi type thing, right? So if you want to get your optimal lens, then you go to one of these, and you'll see what you can get, and then you say, well, could I do better with another lens? And then what do you have to do? Well, you start over at the other company's site, and you say, well, how about the third company? And you go and you try again. Now, if you don't live in the United States, or if you live in some other countries, you have many more companies that have approval on their lenses. Okay, so it's more expensive to get these approved in the United States, so not all companies. So you have a whole bunch of these, and most of them do the same thing. Just to give you an example, these are the ones that are approved in the United States, and I don't think he gave me a laser, but that's life. I can try to do this, yeah. So the amount of astigmatism corrected at the IOL plane, which is the intraocular lens plane, is here, and the one at the corneal plane is there. So there's a correspondence. Thank you. The right one. Right. No. Yeah, here we go. Yeah. Thank you. So this number here corresponds to the amount of astigmatism you can correct from 1.5 to 6, measured where the lens is. But you don't care about this, because your astigmatism that you see with is at the cornea. Now, there's a conversion factor, and for this company and many other companies, they use a constant conversion factor, which is not really accurate. So this is a Sideshow. This is work we've done in the past couple of years, and it shows what the conversion factor should be. So we have done some work, including with Mathematica, and with assistance from Stefan Leibrandt, who's sitting here, in getting this kind of exact conversion, which of course contributes a lot Now, these are the relaxing incisions, these little cuts you would make in the eye, and this is what they correct. So that's an example where they correct half, 0.75, 1.5, 3. So you can see it's also quantized, it's like little jumps. So because it's little jumps, if you happen to have like 1.9 astigmatism, you have a lens that will correct you to 1.5, you have an astigmatism correction correct to 1.5, right? So you're going to be left with 0.4 in both cases. And that's quite a bit of astigmatism. And of course, you have a little bit of uncertainty. If you get a couple of, like a 0.2 or 0.3 of uncertainty from the surgery on this, on top of this, then you're still not clean and nice. All right, so what can we do? So we can combine them, okay? I'm not going to have a lot of time to go through the technique for the combination, but I do want to say that we can focus on this example here. With this example, it's the same one that had 1.9 astigmatism to be corrected, okay? Now, what I can do is to put a toric lens at this angle and to put a relaxing incision at that angle. And that can be computed exactly, all right? So here's sort of the Mathematica or the geometric output, and the core of the talk is here, all right? So it's very abstract, it's not labeled, it's secret. It is filed in a patent that hasn't published yet, or in a patent filing that hasn't published yet. And the point is this. Each one of these circles represents the correction of one of the toric lenses, okay? So let's say, I think this is the 1, this is maybe the 1.5. So if you do 1.5, you can do this. Now your astigmatism is this blue dot. So if you do a 1.5, you are going to be short by 0.4, okay? Now the dotted circles represent the relaxing incisions. And so if you do just the relaxing incision, then again, you're going to be missing your little dot by a certain amount. By if you're doing a 1.5, you're going to be. So the point is that these circles intersect. Okay, so any intersection of the circles gives you a perfect correction of the astigmatism. It gets you to 0. All right? And this has to do with the way that astigmatism combines. So the beauty here is, first of all, I get multiple solutions. So not only do I have one way of reducing, but I have multiple ways of reducing astigmatism. And if you invert the logic a little bit, and you say, you know what? I'm going to have just one lens and one relaxing incision. I don't want to produce any more lenses. I don't want to deal with many complicated ways of cutting the eye. I'm going to do it in only one way. Then, if you do that, then by positioning your incisions properly and your lenses properly, you can actually correct a lot of different values of the astigmatism. Okay, so you can get the whole spectrum. So you kind of develop like a basis from which you construct this high-dimensional space. And this is an example of how this has been done. Okay, so this particular case, 1.9, is corrected in this way. What are the advantages? You can definitely target 0 astigmatism. You minimize the rotation of the intraocular lenses. Remember, I told you this company went out of business completely. The reason it went out of business, well, the company is not out of business, but they don't make these lenses anymore. The reason it started with their lenses rotating. If it rotates, it doesn't give you the correct correction anymore. So you can minimize this by combining with one of these relaxing incisions. It avoids the main cataract incision. Here's your main cataract incision. If you were to only do the cut, it would overlap your cataract incision. That's not good surgically, all right? You have a much reduced basis of required IOLs, simplifies the need for surgical tools, simpler surgery with better outcomes. Okay, so we have a system we have developed. This is prior to this particular edition of this technique that provides for all of these lenses. And the calculator, it has a core calculator, it has a front end and a lens database, and each one of these is universal in the sense that is explained here. So we have, for example, the manufacturers, we have all of the manufacturers included. So you don't have to jump from site to site to site to site to site to site and spend 2 hours or God knows how much time to finally find. All of them are listed and all of them are matched. So it's a little bit like your travelocity of intraocular lenses for cataract surgery, okay? This is an example of the interface. That's fairly recent, actually. It's very, very rich and very flexible. Okay, so putting it all together, that calculation includes the spherical computation for all IOL intraocular lens manufacturers. You have multiple formulas with optimization. You include the correct conversion from lens plane to cornea, okay, which most companies do not do. These are some of my collaborators. Stefan is here, David and Doug. We have intellectual property filed relating to the Zeno 0, okay, for the combination. And we plan to integrate this new zero target method into the calculator I showed you by the end of the year. So thank you very much. I'll take questions.